I'm going to cover some of the questions out of 9.01 today. These are the practice problems out of the lesson, and they're very similar to the questions that you're going to run into on the quiz. So the first question, we're comparing properties of functions written in different ways. I know my ink is apparently getting low, but I'll read through these for you. So the height of 3 kicked soccer balls are modeled by the functions shown below. We have function 1, which says f of x equals x squared plus 2x plus 7. Function 2, we've got values of x going from -3, going straight up to 1. My values of y start at 0, go up to 4, and then go back down to 0. And then we have function 3 here, and let me double check here, but yeah, this graph is going right to 4. So it's not quite crossing 4 for the vertex. All right, so we want to see which ball gets the highest off the ground, which I am going to say which function has the greatest maximum value, because that's what it's asking. Which ball gets the highest off the ground? So you're kicking a soccer ball, it gets at some point in the air and comes back down. So we want to see which one has the greatest maximum value, which is at the vertex, remember. And it's not the x value of my vertex, it's my y value. So like this one, it's just under 4. This one, let's look at how my numbers go again. So as my x values go from negative to positive, my y values start at 0, go up to 4, and then right around here hit 0 again. See? When I get to x is 1, y goes back down to 0. So this is my vertex right here. You see how it has that pattern? 0, 3, 4, 3, 0. That's my max. So my max here is 4. Max here is around 4. It's really hard to see. It looked like it was below 4 when I looked on my computer. And then I have this one here, x squared plus 2x plus 7. I can't just look at this and know what the vertex is. When it's written in standard form, I can't just look at it. And we haven't really learned how to write them from standard to vertex form yet. But there's a workaround. And it's probably a little bit faster, actually, than having to solve it for standard. So my axis of symmetry which is also my x value of my vertex here, okay? That axis of symmetry tells you the x value. That formula is negative b over 2 times a. So if an equation in standard form is ax squared plus bx plus c, then I have an a of 1 and a b of 2. There's no number here for a, but I'm going to pretend like there's a 1 there because that's what we do. So b is 2. So it's negative 2 over 2 times 1. Okay, so negative 2 over 2 is negative 1. So my axis of symmetry is at x is negative 1. Still doesn't give me what I need. I have to go back and plug in the x of negative 1 to solve for y. And that'll tell you what my y value is at my vertex, which is my highest point of my graph. So I'm going to take this equation and now I'm going to plug in the x of -1. So -1 squared plus 2 times -1 plus 7. Exact same equation, just now there's negative ones here. -1 squared is 1. 2 times -1 is -2 plus 7. 1 and -2 and 7 makes 6. So function 1 has a y value of 6 at my vertex. So function 1 is the function that has the greatest maximum value. All right. Okay, now for the next one. Two functions are shown below. Let me rewrite these. 3x squared minus 6x minus 2. And then we've got 0, 1, 2, 3 for my x, and -2, -1, -2, -13 over here. Which function has a greater average rate of change from x equals 1 to x equals 3? So average rate of change is my slope. Right, so I want to find out what my rate of change is from x equals 1 to x equals 3. So here we're going from x equals 1 to x equals 3. Remember, it's change of y over change of x. So y went down 12. It was at -1. And it went all the way down to -13. So y went down 12. X went up 2. So my rate of change for function 2 is -6. This one is not going to be as easy, but they gave me my x values, and I'm just going to plug them in. First, I'll do x is 1. 3 times 1 minus 6 times 1 minus 2. And I said 1, and I still wrote an x. 1 squared is 1 times 3 is 3 minus 6 minus 2. So 3 and -8 is -5. I'm going to just do an XY table, just like they had here, so I could see what the difference is. So when I plugged in an x of 1, I got out -5. Now I'm going to see what happens. And I left some extra room down here, so I've got plenty of space. When x is 3, so I'm going to take the same equation, 3 times 3 squared minus 6 times 3 minus 2. All right, 3 times 9 minus 18 minus 2. Sorry, I'm like miswriting everything today. So that's 27 minus 18, which is 9, minus 2 is 7. So when x is 3, y is 7. All right, so my x values went up 2. My y values went from -5 all the way to 7. So it went up 12. So my rate of change for this is 6. So which function has a greater average rate of change from x equals 1 to x equals 3? This one's was -6 and this was +6. So I would venture to say function 1. Now, if we were looking at the absolute values of these, really this one's going down just as fast as this one's going up. All right, for the last one here, we have x squared. We have f of x is x squared. And then we have g of x, which is x squared plus 4x, and that says plus 4. In which direction and by how many units should f of x be shifted to obtain g of x? Is it left 2 units, right 2 units, up 2 units, down 2 units? It is not easy to compare these like this because, again, sometimes it's easier to look at a function when it's in vertex form. Fortunately for us, this is, think about it. Oh, it's a perfect square quadratic. This is a square, this is a square. All right, so this is x plus 2 squared. Let's just double check, think about it. X plus 2 times x plus 2 would give us x squared plus 4x plus 4. That makes sense. If you want, you can even write them out next side by side and make sure. All right, vertex form makes it so much easier. I am saying plus 2. Here, let me write it in. Your vertex form is x minus h squared plus k. Okay, so I didn't change a. There's nothing there. I didn't change k. There's nothing there. All I did was I added 2 here. I added 2 to x in the parentheses. But this is minus. So remember, whatever you do to your x, it does the opposite because it's already minus here. So even though you think x plus 2, I'm going to go to the right. No, remember, it goes the other direction. So in this, since I'm adding 2 to x, I'm going to go to the left 2 units. Remember, if you added to the y, it would do what you think it does because this is already a plus here. If you change the k value, it goes up or down, like the way you think it would. If you change the h value, it always does the opposite. So this is going to the left. All right, so hopefully that helps you guys.